take a look at tangent of 240. There's a bunch of ways to figure this out. Here's what I do. I'm going to say, if you need to, we can still draw the angle. If you don't need to do that, you don't need to do it if you understand what the reference angle is. So right here, that's 240 degrees. And the idea is that if I find the reference angle, which I call alpha, which is right there, then I can figure out the tangent of 240. Okay? So what does that reference angle have to be? If this is 180 degrees, then how many more do I have to go to get to 240? 60 more. Does that make sense? I'll give you a little formula in a minute if that helps. But for right now, I think we can figure that out. It's 180 half turn, and then it'd have to be 60 more to get to 240, right? So the reference angle by definition is the angle created with the x-axis and the terminal side of theta. The x-axis and the terminal side of theta. That's alpha, okay? So what I do to find the tangent of 240 is I find the tangent of 60 degrees. All right, and then I decide if it's positive or negative. That's it. So I bring everything back to that first quadrant. So the tangent of 60, everybody knows by now, is root 3. Okay? And then I decide if I put a negative in front of it, right? Because the tangent of angles with the same reference angle always have the same value, except it might be positive, it might be negative. And that's the last thing we have to do to figure that out. Very good. In quadrant 3, tangent is positive because x and y are both negative, so tangent is positive. So that's my answer. The tangent of 240 is actually the same as the tangent of 60, right? Because tangent is positive in 1 and 3. Okay. Let's do the rest of them. Maybe we can do these a little bit quicker. Cosine of 135. If you want, you can draw a picture. Right, that's 135. Right here, that's the angle I'm interested in. And I got to understand that it'd be 45 more degrees to get to 180. Right? So that means if I want to evaluate the cosine of 135, then I'm going to evaluate the cosine of 45, which everybody knows is what? It's an easy one. Root 2 over 2. Alright, and then I decide, so that means the cosine of 135 is root 2 over 2, but it might be negative. Right, and then I decide if I attach a negative. Is cosine and negative in quadrant 2? Yes, right, because the x value is negative there. Okay, so that's my answer. Again, I'm finding all these by referencing. Let's see if we can do sine. Well, sine 270 is a little bit different. It doesn't really have a reference angle. This one I do a little bit differently. That's what we call a quadrantal angle. It lands in between two quadrants. So it doesn't have a reference angle. There is no angle created really with the x-axis and the terminal side. So how do we do this problem? We rely on our definition. The sine of 72, the sine of an angle is y over r. What's the relationship between y and r here? Y is the distance from here down, right? That's y. What's r? Same thing, right? Almost the same thing. R is just the positive of that, right? So really it's just, we're going to talk about the unit circle today, so I could call this whatever I want, this point. It could be 0, negative 8, or it could be 0, negative 1. Doesn't matter. All right, whatever that point is, I'm going to get the same value for sine. It's just a ratio of y to r. So it doesn't matter what I call that point. If I use 0, negative 1, then that means y, negative 1, r is 1. Sine of 270 is negative 1. Okay. And let's do 2 more. Cotangent of negative 150. What I'm going to do, so we'd have to think a little bit about this one a little more because I got to deal with the cotangent. So what I'll do is I'll find the tangent of negative 150, and then I'll flip it upside down. Okay? Take the reciprocal. So tangent of negative 150, you can draw a picture if you want. At some point, I'm hoping we don't need to draw the picture. We'll be so familiar with these, we'll say, okay, negative 150 in your head, you can picture the reference angle is what? What's the reference angle? Can anybody do that? 30 degrees. right? 30 degrees because negative 150 would go like that, which leaves you with 30 more to get back to the negative 180. Right, so that's a reference angle of right here of 30 degrees. So I'm going to find the tangent of 30, and then I'll decide if I have to make it negative. Or we can decide that now, right? The tangent of 30 is going to be equivalent to the tangent of negative 150 because we're in quadrant 3 again. So if you're positive in quadrant 1, tangent 30 is positive, then you're positive in quadrant 3 for tangent function, right? Positive in 1 and 3. So everyone knows tangent of 30 is root 3 over 3. So that means the tangent of 150 is root 3 over 3, right? Negative 150, which means the cotangent of negative 150 is the reciprocal. So my answer then is 3 over root 3, which is 3 root 3 over 3, which is root 3. All right, that'll reduce to root 3. Running out of room. That's my answer. Root 3. Okay. One more, secant of 210. 210 goes that way. That's the same angle, right? Or at least it's coterminal, I should say, to negative 150. Puts me in the same place. So again, if I'm dealing with the secant function, first thing I want to do is find the cosine of 210. So what's the cosine of 210? How about, what's the reference angle? I look at the cosine of 30, and then I decide if I want to make it negative or not. What's the cosine of 30? Everybody knows. That's root 3 over 2, right? So that means the cosine of 210 is also root 3 over 2, but I might have to make it negative. Is cosine negative in quadrant 3? Yes. Okay, so I know that now that the cosine of 210 degrees is negative root 3 over 2. That means the secant of 210 degrees is negative 2 over root 3. Right, the reciprocal of that. So that would be negative 2 root 3 over 3 if I multiply by root 3 over root 3.